The transponder panel is located on the aisle stand. The transponder selector selects either the left or right transponder for use. The selected system displays in the code window. Select the right transponder. Notice the display change. The code selectors are used to set the assigned code. The ident switch is used to transmit an identification signal. The mode selector is used to select the various modes. During pre-flight, set the mode selector to standby. Just before takeoff, the selector is set to TARA. The TA only and TARA modes are discussed in other lessons. The selected transponder activates automatically when the airplane is airborne. The weather radar system includes 2 receiver transmitters and 1 antenna. Controls for the weather radar are located on the aisle stand and HSI control panels. Weather returns are displayed on each pilot's HSI. Moving this switch selects either the left or right weather radar system. The weather switch on each HSI control panel activates the radar and displays radar data on the related HSI. For this lesson, let's use the left side controls. Turn on the weather radar display. The selected radar mode and antenna tilt angle are shown here. Radar range corresponds to the selected HSI range. The mode selector is used to select the desired radar mode. In the weather mode, only weather returns due to precipitation are displayed. Selecting the weather and turbulence mode displays both weather and turbulence returns. Notice the corresponding change in the radar system indications. The map mode displays ground returns and is discussed later. The returns display in 4 different colors. The colors of the indications depend on the intensity of the precipitation. Areas of light precipitation are green. Moderate precipitation is shown in amber. Red displays depict the areas of heaviest precipitation. Areas of turbulence within precipitation are shown in magenta at display ranges of 40 miles or less. Precipitation must be present for magenta returns to appear. The radar cannot detect clear air turbulence. Return brightness is controlled by the inner brightness control for the HSI. Radar returns are displayed in VOR, approach, map, and center map modes only. Let's look briefly at ground mapping. Select the map mode. Now adjust the antenna tilt to -2 degrees. When ground mapping, incremental tilting of the antenna during successive sweeps of the beam is required for a comprehensive display of the terrain. If required, gain should be adjusted for optimum observation of terrain features. When the gain control is set to the auto position, the radar receiver is set to optimum sensitivity for best radar display. The gain can also be controlled manually by rotating the gain control. This indication appears when the gain control is not in the auto position. Now, return the gain control to the auto position. After landing, turn off the weather radar system. Now, let's look at some non-normal conditions and indications. Failure of a transponder is indicated by the illumination of the amber transponder fail light on the control panel and the ATC fault advisory message on TCAS. Radar system fault indications display on the HSI in amber. Some radar system faults may occur which allow limited system operation. Weather returns may continue to display depending on how severe the malfunction is. These are possible annunciations indicating limited operation. Radar system failures are indicated by the weather radar fail annunciation. When a failure occurs, weather returns and radar system indications are not displayed. The Ground Proximity Warning System, or EGPWS, provides the crew with alerts associated with terrain clearance and vertical flight path deviation. This new enhanced ground proximity warning system has added look-ahead terrain features, which should help prevent controlled flight into terrain. The EGPWS has many new features, including terrain display on the HSI. The terrain display shows a dotted pattern to differentiate from the radar display. However, radar weather and terrain cannot show at the same time. One pilot can display terrain and the other pilot weather radar. The EGPWS provides a look-ahead warning, predicting flight into vertically shear terrain. And alerts pilots of slow descent into terrain while in the landing configuration. The system uses GPS position and FMC and air data inputs, combined with an internal terrain map and airport database found in the EGPWS to project potential terrain conflicts. The EGPWS includes two master warning lights, a ground proximity glide slope inhibit switch, a ground proximity flap override, a ground proximity gear override, and a ground proximity terrain override switch. Oral annunciations are broadcast over the flight deck loudspeakers. Terrain display on the HSI can be selected manually with the terrain switch on the HSI control panel. Display terrain on the HSI now. Terrain color display is green, with caution terrain in amber and warning terrain in red. If you see a dot magenta pattern, there is no terrain data available for that area on the map. These dotted colors become the terrain patterns you see on the HSI. Red terrain is more than 2,000 feet above airplane altitude. Amber terrain is from 500 feet below to 2,000 feet above airplane altitude. green terrain is 500 feet below to 2,000 feet below airplane altitude. Terrain is not shown if more than 2,000 feet below airplane altitude.
Caution, terrain, caution, terrain.
The dotted pattern becomes solid amber when the computer calculates that you will hit the terrain within 40 to 60 seconds. An amber terrain message shows on the navigation display and a voice alert sounds.
Terrain, terrain, pull up.
The dotted red terrain becomes solid red when the computer calculates that you will hit the terrain within 20 to 30 seconds. Solid red terrain shows on the navigation display, a voice alert sounds, and pull up appears on the ADI.
Terrain, terrain, pull up.
It is displayed automatically when a look-ahead caution or warning alert activates. All EGPWS alerting functions will operate with or without the terrain display selected. Between 30 and 2,450 feet radio altitude, the ground proximity warning system alerts the flight crew when certain thresholds are exceeded. These thresholds are excessive and severe descent rate, excessive terrain closure rate, altitude loss after takeoff or go-around, unsafe terrain clearance when not in the landing configuration, excessive glide slope deviation, wind shear, excessive terrain closure rate with flaps in landing position, deviating from a selected altitude, and excessive bank angle. The Warning Electronic System, or WES, and the EGPWS work together to provide 7 ground proximity alerts. Let's look at these 7 alerts in more detail.
Sink rate, sink rate.
If airplane barometric descent rate becomes excessive, the sink rate oral caution sounds twice and the ground proximity light illuminates.
Pull up, pull up.
For rapidly building sink rates near the ground, a time-critical warning activates. A pull-up oral warning sounds, a red pull-up light illuminates, and the master warning lights illuminate.
Terrain, terrain.
During excessive closure rate to terrain, the alert terrain, terrain sounds based on decreasing radio altitude.
Pull up, pull up.
The alert changes to a time-critical warning. The pull-up warning sounds repeatedly until 300 feet of barometric altitude have been gained. A red pull-up light illuminates and the master warning lights illuminate.
Terrain.
A less sensitive envelope to reduce nuisance alerts is provided during takeoff, approach, and landing. If the airplane penetrates the envelope with gear and flaps in the landing configuration, terrain is repeated until the airplane has gained altitude.
Don't sink, don't sink.
If barometric altitude decreases excessively during the initial takeoff, climb, or during a go-around, the don't sink oral caution sounds twice and the ground proximity light illuminates. The caution continues until a positive rate of climb is established.
Too low, terrain, too low, terrain.
When operating below 1,000 feet radio altitude at high airspeeds, The too low terrain oral caution sounds and the ground proximity light illuminates.
Too low, gear, too low, gear.
At low air speeds, the ground proximity light illuminates and the too low gear oral caution sounds if the airplane is approaching terrain with the landing gear retracted.
Too low, flaps, too low, flaps.
When the landing gear are extended but the flaps are not in a landing position, the ground proximity light illuminates and the too low flaps oral caution sounds.
Glide slope, glide slope.
An excessive glide slope deviation arms below 1,000 feet radio altitude with the landing gear extended. If the airplane deviates excessively below an ILS glide slope, the glide slope oral caution sounds repeatedly and the ground proximity light illuminates. Initially, the oral sounds at 1/2 the volume of the other oral alerts. Repetition rate of the oral alert increases as glide slope deviation increases and as radio altitude decreases.
Glide slope, glide slope, glide slope.
If deviation below the glide slope remains excessive, the glide slope oral caution changes to full volume.
Bank angle, bank angle.
A one-cycle oral warning bank angle sounds when roll angle exceeds 35, 40, and 45 degrees. Once the warning sounds, it will not sound again until roll angle decreases below 30 degrees and again exceeds 35 degrees. 400, 300.
Minimums.
The voice call-out of minimums occurs when reaching the decision height set in the captain's decision height reference window.
20, 500, 1,000, 50, 40, 30, 20, 10.
The GPWS provides call-outs of 2,500, 1,000, 50, 40, 30, 20, and 10 feet radio altitude during approach and landing. Once the altitude has been called out, it will not function again until the airplane climbs through 1,000 feet radio altitude. Let's look at the controls that are used to operate the GPWS.
Terrain, terrain. Pull up.
Pushing a master warning light reset switch only resets the master warning lights. The pull-up message for excessive descent rate and excessive terrain closure rate remains active until the conditions no longer exist. Now, let's look at the GPWS alerts that can be inhibited or canceled. Pushing the ground proximity glide slope inhibit switch cancels an active excessive glide slope deviation alert.
Glide slope, glide slope.
Cancel the glide slope alert.
Glide slope, glide slope, glide slope.
Returning to the glide slope also cancels an active caution level alert. Raising the switch guard and pushing the ground proximity flap override switch inhibits the ground proximity flap alerting function should a landing with less than landing flaps be required. Inhibit ground proximity flap alerting. Raising the switch guard and pushing the ground proximity gear override switch inhibits the ground proximity gear alerting function should a gear up or partial gear up landing be necessary. Inhibit ground proximity gear alerting. Pushing the ground proximity terrain override switch inhibits the look-ahead terrain alerts, terrain clearance floor alert, and terrain display. The ICAS alert message terrain override displays. Inhibit terrain alerting now. During pre-flight operations, check that the ground proximity light is not illuminated. The switch guards are closed, and override is not visible on the gear, flap, and terrain override switches.
Wind shear, wind shear, wind shear.
If wind shear conditions are detected, an oral warning consisting of a two-tone siren followed by wind shear repeated 3 times activates. A red wind shear message displays and the master warning lights illuminate. When the wind shear alert is active, all other ground proximity modes are inhibited. A wind shear warning remains active until wind shear conditions are no longer detected. The Predictive Wind Shear System, or PWS, uses wind velocity data gathered by the Doppler weather radar system to identify the existence of a wind shear. The PWS then provides pilots with cautions and warnings of wind shear threats. PWS alerts are enabled below 1,200 feet AGL. The radar turns on automatically during takeoff, using thrust lever logic to provide wind shear warning coverage 3 nautical miles ahead of the airplane. In flight, warning coverage is provided 0.5 nautical miles to 1.5 nautical miles ahead of the airplane. Caution coverage is provided from 0.5 nautical miles to 3 nautical miles. There is a blind area in front of the airplane out to 0.5 nautical miles.
Monitor radar display.
In an area of thunderstorm activity, turn on the weather radar. The display shows the difference between the wind shear position and the normal weather pattern presentation. Also, the HSI does not display weather in plan mode, centered VOR mode, or centered approach mode.
Monitor radar display.
If a wind shear condition is detected in the caution region, an oral alert monitor radar display sounds. The amber wind shear appears on the HSI, and the position of the detected wind shear is shown on the map display.
Go around. Wind shear ahead.
If the wind shear is detected in the warning area, an oral warning "Go around wind shear ahead" sounds. The red wind shear appears on the HSI, and the position of the detected wind shear is shown on the map display. A red wind shear message displays on both ADIs, and the master warning lights illuminate.
Wind shear ahead. Wind shear ahead.
If wind shear is detected during takeoff roll, rotation, or climb out, the voice alert "Wind shear ahead" sounds. The wind shear position displays on the HSI, the red wind shear displays on both ADIs, and the master warning lights illuminate. If the ICAS message "Wind shear system" appears, wind shear alerts may not be provided. Wind shear alerts which do occur are still valid.
Descend. Descend. Clear of conflict.
The Traffic Alert Collision Avoidance System, or TCAS, helps to maintain safe traffic separation by providing alerts, flight path guidance, and traffic displays to the flight crew. TCAS is independent of ground-based ATC systems. TCAS information displays on the captain's and first officer's HSI and ADI. Voice alerts are broadcast over two flight deck loudspeakers located on the left and right sidewalls. The TCAS displays traffic advisories and alerts on the captain's and first officer's HSI. TCAS also displays vertical flight path guidance commands on the captain's and first officer's ADI. Now let's take a look at how TCAS works. The TCAS and Mode S transponder determine range, bearing, and altitude of other transponder-equipped aircraft. With this information, TCAS is able to predict the closest point at which your airplane and another aircraft will approach each other. TCAS provides a three-dimensional area of protected airspace around the airplane. The actual shape and size of this area varies greatly depending on altitude, bearing, range, and speed, but for simplicity, it is shown here as spherical. A traffic advisory, or TA, is considered a caution level alert and is issued if TCAS predicts that another aircraft will pass close enough to be considered a potential threat. The TA is issued 35 to 40 seconds before the aircraft reaches what TCAS determines to be the closest point of approach.
Traffic. Traffic.
An oral voice alerts the crew to scan visually for the traffic. A resolution advisory, or RA, is issued if TCAS predicts that the two aircraft will not have adequate separation. The RA is issued 20 to 30 seconds before the two aircraft reach their closest point of approach.
Descend. Descend.
TCAS issues an oral voice command and displays vertical flight path guidance commands on the ADIs. We'll talk about the vertical guidance commands in a few minutes.
Clear of conflict.
Notice that the conflicting traffic climbed to a higher altitude as your airplane descended. If both airplanes are equipped with TCAS and a Mode S transponder, coordinated commands are issued. A voice oral advises the crew when the traffic conflict no longer exists. Proximate traffic is another aircraft that is not classified as a TA or RA and is within 6 nautical miles and 1,200 feet vertically. Other traffic is another aircraft that is not classified as a TA, RA, or proximate and is farther than 6 nautical miles or greater than 1,200 feet vertically from the airplane. There is no oral voice with this type of alert. TCAS does not detect or provide traffic avoidance information for non-transponder equipped aircraft. Now, let's look at the TCAS controls and indications on the flight deck. When TCAS is off, a TCAS off annunciation displays here on the HSI. TCAS is selected on with the transponder mode selector. Normally, TCAS is operated in the TA-RA mode. In that position, the transponder is on, and both TA and RA alerts are armed. Select the TA-RA mode. The TCAS off annunciation is removed, indicating that TCAS is on. but one more step is required to display TCAS information. A traffic switch on top of the HSI range selector is used to display TCAS information on the HSI. Push the traffic switch. TFC displays here on the HSI, indicating TCAS information has been selected for display. Pushing the traffic switch again removes displayed TCAS information.
Traffic. Traffic.
The traffic oral voice alert sounds twice, indicating that TCAS has issued a TA. The detected traffic is beyond the current range of the HSI, as indicated by the amber off-scale message. Select a range of 20. The off-scale message changes to traffic. An amber traffic target now displays, indicating the relative position of the conflicting traffic. A plus sign indicates that the traffic is above your airplane, and the numbers indicate relative altitude separation in hundreds of feet. In this example, the traffic is 900 feet above your present altitude. An up arrow indicates the other aircraft is climbing at more than 500 feet per minute. Maneuvering is not required for a TA. Simply attempt to establish visual contact. TCAS and weather radar may be operated at the same time. Display the weather radar returns. Displaying weather radar has no effect on TCAS displays.
Descend. Descend.
Now, let's look at how TCAS presents resolution advisories information. The RA displays as a red square. In this example, the traffic is 300 feet above you. The absence of an up or down arrow indicates that the traffic's vertical speed is less than 500 feet per minute. TCAS displays a red vertical guidance symbol on both ADIs. Maneuvering is required for an RA. Pitch attitude must be adjusted to move the airplane out of the red areas. Since maneuvering is required, first disengage the autopilot and disconnect the autothrottle. Then smoothly establish a descent to move the airplane symbol out of the red outlined area. The maneuver is not aggressive or abrupt. You may continue adjusting pitch attitude and vertical speed as long as you remain outside of the red area. Always attempt to establish visual contact with the traffic.
Clear of conflict.
Once clear of the traffic, a voice oral announces that the RA is over. RA guidance is removed from the ADI, and the RA symbol changes to a TA symbol. Smoothly return to your assigned altitude when the TCAS event is over, and re-engage the autopilot and autothrottle. As always, coordinate with ATC as necessary. When traffic is not a potential threat, it becomes proximate traffic. Proximate traffic displays as a solid white diamond. As the traffic continues to move farther away, it changes to other traffic and displays as a hollow white diamond. In this example, the traffic has leveled off at 2,000 feet above your airplane and is headed away from you.
Descend. Descend.
A no bearing alert is displayed if TCAS cannot determine the relative bearing of the conflicting traffic. Since the relative bearing is not known, the alert is displayed in text format. The red RA indicates that the alert is a resolution advisory. The traffic is presently at a distance of 4.9 nautical miles, 400 feet above your airplane, and climbing at more than 500 feet per minute. Since the no bearing alert is an RA, the appropriate audio alert is issued and the red vertical guidance symbols appear on the ADIs. As before, disengage the autopilot, disconnect the autothrottle, and maneuver the airplane to avoid the red area. Again, always attempt to establish visual contact with the traffic.
Traffic, traffic.
TCAS can handle multiple aircraft and has just identified a second potential threat and issued a no-bearing TA. Again, relative bearing and heading are unknown. The traffic is 5.2 nautical miles away, 2,100 feet below you, and climbing at more than 500 feet per minute. Since this is only a TA, continue the flight path for the RA.
Clear of conflict.
TCAS determines that distance from the first traffic conflict is adequate. The RA changes to a TA and the vertical guidance symbol is removed from the ADIs. Smoothly return to the assigned altitude and re-engage the autopilot and autothrottle. Remember to coordinate with ATC. TCAS no longer considers the first traffic alert a potential threat and cancels the TA. The second alert moves up one line on the display. When the second traffic alert is no longer considered a potential threat, it is also removed from the HSIs. TCAS does not issue no bearing alerts for proximate or other traffic. Now, let's look at some other RA displays and guidance commands.
Descend, crossing, descend. Descend, crossing, descend.
TCAS issues an RA for traffic that is presently below your airplane and climbing at more than 500 feet per minute. Notice that when traffic is below your airplane, the altitude data has a minus sign and appears below the traffic symbol. RA guidance on the ADI is commanding a descent. Descend, crossing, descend means that your current flight path descends through the altitude of the traffic.
Increase descent, increase descent.
Disengage the autopilot, disconnect the autothrottle, and adjust pitch attitude to establish a descent. Increased descent warns that TCAS has determined that the present rate of descent is not sufficient to maintain safe traffic separation. The recommended technique is to establish a pitch attitude that places the airplane symbol just outside the red outlined area. Remember, always attempt to establish visual contact with the traffic.
Clear of conflict.
Traffic separation is increasing and TCAS cancels the RA. The traffic displays as a TA and maneuvering is no longer necessary. Smoothly return to the assigned altitude, re-engage the autopilot and autothrottle, and advise ATC of your actions.
Climb, crossing, climb. Climb, crossing, climb.
RA guidance on the ADI is commanding a climb. Climb, crossing, climb means that your airplane will climb through the altitude of the traffic. Maneuvering for this RA is similar to the previous example, except a climb is required. Use the same techniques described previously to maintain safe traffic separation.
descend, descend.
Here is a situation where the traffic is above you and climbing, and TCAS issues an RA command to descend. Again, disengage the autopilot, disconnect the autothrottle, and smoothly fly the airplane out of the red area on the ADI. TCAS continues to monitor the traffic and determines that the approaching aircraft has just entered a descent that will place it too close to your airplane.
Climb, climb now. Climb, climb now.
TCAS recomputes the path of the traffic and issues a revised RA. Vertical guidance on the ADI changes to a climb, and climb, climb now commands an immediate climb to maintain safe separation. As always, attempt to establish visual contact with the traffic.
Clear of conflict.
Once clear of the traffic, the RA is canceled and the traffic display changes to a TA. Return to the assigned altitude, re-engage the autopilot and autothrottle, and coordinate with ATC. All TCAS alerts are inhibited by EGPWS and wind shear alerts. Increased descent RAs are inhibited below 1,450 feet radio altitude. Descend RAs are inhibited below 1,100 feet radio altitude. All RAs are inhibited below 1,000 feet radio altitude. All TCAS voice alerts are inhibited below approximately 500 feet radio altitude. There are two ICAS advisory messages associated with TCAS non-normal conditions. The messages are for awareness only and crew action is not required. When the traffic switch is pushed and the transponder mode selector is in a position other than TA or TARA, the advisory message TCAS off displays on ICAS. The message TCAS off also displays on both HSIs. When the traffic switch is pushed and the transponder mode selector is in either of the TCAS positions, the advisory message TCAS displays on ICAS, indicating that TCAS has failed. A TCAS fail message also displays on both HSIs. In the event of an engine failure, the TA mode should be selected to prevent RA climb commands which could exceed single engine performance capability.